Hello everybody and welcome back. We're on question number 19 in this video of our 2019 Pascal. There are 6 identical red balls and 3 identical green balls in a pail. 4 of these balls are selected at random. I smell a probability question. And then these 4 balls are arranged in a line in some order. How many different looking arrangements are there? Oh, okay, so it's not a probability question. So, the balls are identical. But there are 2 different colors. So we're really asking ourselves, well, how many ways are there to arrange the colors? I'm going to break this down with some cases. So what could we have? Well, we could have 4 red balls, but there's really only one way to do that. Okay? Now, maybe we don't have 4 red. Maybe we only pick 3 red. Well, then you'll have to pick 1 green because you've got 4 balls picked in total. Now, the question is, where's that green ball going to go? We've got 4 positions, and the green ball could go in any one of them. So you have the green at the end. You could, I've got my ordering wrong for some reason. You could have the green at the start, green in the 2nd position, green in the 3rd position, green in the 4th position. There's one way with 4 red. There's 4 ways with 3 red and 1 green. Okay? Maybe we don't get that. Maybe we get 2 red. Well, then you'll have to get 2 green. Now, how many ways are there to arrange 2 red and 2 green? Well, this is the number of ways to choose out of an ordering of 4 things, the positions of 2 reds or 2 greens. And this might be recognizable to some of you as 4 choose 2. And if you know that, if you know a little bit of combinatorics, you'll know the answer is 6. If you don't, you can forget about that. You can just sort of try and be organized and find the various cases. So here I've got 3 situations the reds and greens can be in. And then we can find some more. So we can get green in first. And I'm just trying to be organized, putting red first as much as I can, and I'm moving the other red over one at a time. And the greens are just filling in the rest of the gaps. This is very much, we've got the reds, just put the greens in where they need to go. Okay. We can get our other possibilities here. And there are only 6 ways to do this. Now, what if I have only 1 red and 3 greens? Well, that's going to be this case. Just change all the reds to greens and the greens to reds. That's it. That's all you'll have to do. You can certainly write them out if you want to. That's what I'm doing. But you don't really need that. It's just a question of, well, where do you put that 1 red that you've got? Well, 4 possible places, so 4. Now, if we could have 4 green, there'd be only one way to do that. But here's where we have to read the question a bit carefully. There are 6 identical red balls, so it's entirely possible that all the balls could be red when you pick them. But can we have all 4 of these balls be green? Well, no, we've only got 3 green balls, period. So this isn't a possibility. We have to be careful. We don't want to get excited and forget the conditions of the problem. So we need 1, 4, 4, and 6. And that adds up to 15. So our answer here is going to be 15. There it is, it's A. Now there's another way you could go about doing this question without writing out cases or trying to figure out, if you're worried about the 6 that maybe I missed a case or something. Here's another way you could approach the question. Now imagine that we had the balls. And imagine for a moment we had as many green balls as we need and as many red balls as we need. You pick the first ball that you're ordering. What could it be? Well, it could be red or it could be green. You pick the next ball. It could be red or it could be green. The next ball, it could be red or it could be green. For each of these possible ball orderings, we have 2 choices. 2 choices, 2 choices. And my choice of is this a red or a green doesn't affect whether or not the next one's going to be a red or a green. That doesn't change my arrangement. So what we could do is we could say that there's 2 times 2 times 2 times 2. There's 16 ways to arrange red and green balls. And that's great. And then you'd say, aha, the answer is B. But remember, we can't just freely pick green balls. So we have to subtract the 1 case with 4 green, because we know that that'll never happen. So it's 16 minus 1, and that's how you get 15. Because again, the 4 green case cannot happen. But you'll notice 1, 4, 6, 4, 1 would be 16. That is all the ways to put red and green balls in some nice linear order. But one of these possibilities can't happen because we only have so many green balls. So we got to watch out. Okay? So either do this sort of total, subtract the things we can't have, or the other method where we just add up the various cases that we can have. We still get our answer of A, 15. Okay? A nice little question. So I'll see you for more of our Pascal in the next video. Until then, take care.